Greetings, it is Mr. Kingsbury. We are back here with some Algebra 2 notes. That's our subject we're studying today. The unit is still absolute value, and today our topic is solving equations. This will be part 1 of 2. Again, I am Mr. Kingsbury. Don't forget to put the date, and don't forget to put what period you have me. Our question today, our essential question today, is very simple. How do I solve an absolute value equation? And the answer is that it's not that much different than solving a regular equation. There are a couple things that you have to be aware of, though. So for starters, I don't know if you've noticed, but the graph of an absolute value function looks an awful lot like two linear functions that cross. And that is true. That's absolutely true. What's happened is there are two linear functions and we have limited the domain on each. When we solve, we get to a point where we have to remove the absolute value bars in order to solve. And when that happens, this part of the equation, of both equations, that has been eliminated and is not really part of the absolute value equation, comes back into play. The result is that we may get an answer that doesn't actually work, and I'll show you that. We call that an extraneous solution. Extraneous solution. This is a solution that looks like it should work, but does not. So what I thought I would do is just go through a couple of equations with you. I think I have 3 examples, and then we'll be done. So let's start with example 1. We have 3 times the absolute value of x plus 5 equals 26. And this is actually a really good one to start with because, as you'll see, it's pretty straightforward and simple. Before you can do this stuff inside the absolute value area there, you got to get rid of these things on the outside. I like to use the metaphor of jail. We're trying to break our buddy out of jail, and these bars are the jail. Before I can do that, I got to get rid of my 2 guards here, and then I've got to open the gate somehow, or open the door to his cell somehow. So the first step is to get rid of this 3 and this 5. Now you can technically get rid of either one. I'm going to tell you that if you get rid of the 3, you'll have to do it with division, because this is 3 times the absolute value of x. And if you divide, you'll need to divide this 5 and the 26 as well. Typically, it's safer and easier to cancel out the addition or subtraction part first. So I'm going to subtract 5 from both sides. Now that means that these cancel out, and 26 minus 5 is 21, and that leaves 3 times the absolute value of x. Then I will cancel this 3. This is 3 times x, so I will divide by 3 here, and I am just running out of lead. Yeah, of course, right in the middle of my video. It's okay, I got more pencils. Not a problem. Here we go. Here's hoping I don't break this lead. I did that a lot in the last video. So I'll divide both sides by 3. On the left side, these 3's, they essentially simplify out. 3 divided by 3 is 1. So this is like 1 times the absolute value of x, which is just the absolute value of x. 21 divided by 3 is 7. So far, I haven't done anything you wouldn't do on a normal equation. Now for the part that's different. Because this is the absolute value of x, there are actually 2 things that could give me 7. X could be equal to 7, or x could be equal to negative 7. Remember, absolute value calculates the distance from x to 0, or from 0 to whatever your number is. So how many units is it from 0 to 7? That would be 7 units. How many units is it from 0 to negative 7? That would be 7 units. So both of these numbers, if plugged into absolute value signs, would give me a 7. Now that means then that there's a possibility that one of them might not work. So I'm going to have to check and make sure they work. You go back to the original equation, though, and you evaluate it. So I'm going to start by plugging 7 in here. 3 times the absolute value of 7 plus 5 should equal 26. And from here, what you can do is, I like to type it in the calculator and just evaluate it straight up. That's all I really need to see as far as your work. I need to see what the equation looks like with your number or your solution plugged in, and then I need to see what it evaluates to. So I'm going to hit 3. I don't know if you can see. I'm going to hit 3 down there. And then alpha and window, and I'm going to choose option 1, absolute value. In that, I'm going to put my number that I'm checking, 7. I'm going to hit the right arrow to get out of there, and then I'm going to put plus 5, and I'm going to hit enter, and I got 26. So is 26 equal to 26? You bet it is. Same thing on the other side. I'm going to go 3 times the absolute value of 7 plus 5, hopefully equals 26. Let's go back to our calculator here. So 3, alpha window, absolute value. This time I'm putting negative 7 in there. Going to hit the right arrow to get out of there. Plus 5, enter, and I get 26 again. So both of them work. That's awesome. That's exactly what I want. I'm going to flip to the next page here, and I'm going to show you just a couple more examples. I'm going to do that in each example too. You got to check for those extraneous solutions. And on the test, we will put problems, especially multiple choice problems, where some of the answer choices have the extraneous solutions in them, because we want you to be sure about your answers. So here's the next one. Let's do this. The absolute value of x plus 8 equals 5x. Now again, I want to look and see if there's anything outside the absolute value signs, if you will, the guards. There are not. And if you recall, on the last problem, the way I got the absolute value signs to disappear or go away is I rewrote the problem one time just as is, and the other time I changed the sign to negative. So I'll do the same thing here. I will write x plus 8 equals 5x, and I will write x plus 8 equals negative 5x. And I will solve them both. So let's start with this one. There's a couple ways you could start this. Because there's only x's on the right, I'm going to get rid of this x on the left. Okay, there's an x and a constant on the left. So I'm going to subtract x from both sides. And what that does is put all of my x's on the right. 5x's minus 1x is 4x's. These x's cancel out, and it leaves me with just 8. So I have 8 equals 4 times x. And if I divide both sides, this is 4 times x. So to undo times, we divide. So if I divide both sides by 4, 8 divided by 4 is 2. 4 divided by 4 is 1, and 1 times x is x. So I have 2 equals x. Now let's try this other one. Over here, I'm going to do the same kind of thing. Again, x is only on the right, and then I have an x and a constant on the left. So again, I'm going to subtract x. Something interesting happens. On the left side, the x's still cancel. I still have 8. On the right side, though, I'm dealing with negative 5x, not positive 5x. Negative 5x minus 1x is negative 6x. So I now have 8 equals negative 6 times x. And I will divide both sides by negative 6. And I get, on the right, 8 divided by negative 6 is, it's probably going to be a nasty decimal. It is. I divided it in here. And I got negative 1.333. I'm going to hit math, enter, enter. And that puts it back in fraction form. So I get negative 4/3. That's kind of tiny. Negative 4/3 equals, and over here, negative 6 divided by negative 6 is 1. 1 times x is x. Again, I need to check my answers. So let's start with the easier one. Let's plug 2 into our original equation. And I need to plug it into both this x and this x. So I'm going to have the absolute value of 2 plus 8 will equal 5 times 2. One of the reasons I like this problem is because it shows you how you're supposed to be solving. A lot of times students don't quite understand what you're doing when you're checking your work because one side is already a number. What you're doing is evaluating each side separately and then seeing if you get the same number. So 5 times 2 is 10. 2 plus 8 is 10, and the absolute value of 10 is 10, so that works. On the other side, we will have the absolute value of negative 4/3 plus 8, and that should equal 5 times negative 4/3. And I got to be honest, I'm not entirely sure what these are. So I'm going to go to my calculator. I'm going to hit second and window and choose absolute value. And inside the absolute value bars, in parentheses, I'm going to put negative 4 divided by 3. Then I'm going to go plus 8. I'll arrow out, I hit enter. And I'm not sure what that is, so I'm going to hit math, enter, enter. And we got 20/3. Now I'm going to do this side. So I'm going to type 5, and in parentheses I'm going to put negative 4 divided by 3. And I might as well hit math, enter, enter. And I get negative 20/3. Is 20/3 equal to negative 20/3? The answer is no. So is negative 4/3 a solution? No. So the only one that is in this case is 2. That's why we have to check it. It looked like negative 4/3 was a solution, but it was not. Lastly, we've got the absolute value of 2x minus 1 equals negative 5. And you'll note I have a negative 1 outside of my absolute value, so I'm going to go ahead and add 1 to both sides. That gives me the absolute value of 2x equals negative 4. Remember, these cancel. So I've gotten rid of the guard. Now I need to open the cell. So in order to do that, I drop the absolute value bars. And in one case, I just write what's here. 2x equals negative 4. In the other case, I will write 2x equals, but instead of negative 4, I will change the sign and put positive 4. So let's solve this one first. This is 2 times x equals negative 4. We undo times with division, so I will divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. Negative 4 divided by 2 is negative 2. So I get that x equals negative 2. Here's hoping. Let's go ahead and check that. So I'll go back to the beginning. I've got the absolute value of 2 times x. Only instead of x, I'm going to put negative 2 this time. And then minus 1 should equal negative 5. And this is where I can go to my calculator. And I hit a button, sorry. So we're going to go alpha, window, enter. And in there we will go 2 times negative 2. Then I'll hit the little right arrow. And I go minus 1, and I hit enter. And I get 3. Is 3 equal to negative 5? The answer is no. No, it is not. So that means negative 2, not a solution. Let's try the other one. We will again divide both sides by 2. Again, 2 divided by 2 is 1, and 1 times x is x. 4 divided by 2 is positive 2. So let's see if positive 2 is a solution. We're going to plug that in. We got the absolute value of 2 times 2 minus 1 hopefully equals negative 5. Let's go back to the calculator here. Alpha, window, absolute value, 2 times 2, right arrow, minus 1. I hit enter, and I get positive 3. Once again, I ask, is positive 3 equal to negative 5? And once again, you will tell me, So that means neither of these are solutions, which means there is no solution. Now we'll practice more of this in class, and there are some more difficult problems on the horizon, but for today, for now, I think that's enough.